This is substitution in 2 minutes and going through an actual A-level maths example. So S equals UT plus half AT squared. So putting in the numbers, we literally substitute them in brackets as if they're almost like football players just being put onto the pitch. Okay, so U is here, and then T is 3. We put them in brackets. They're bringing themselves on the pitch. Then A is going to be 4 in brackets, and then T is going to be 3 in brackets, but don't forget the square, okay? And then that has to all equal S. So S is going to be minus 15 plus 2 times by 9. So it's going to be 18. So S therefore equals positive 3. Cool. Now there's another little question that this can actually help us answer. In maths, what if a ball was being launched up in the air and then comes back down again? I want to know what would be the speed of the ball once it comes back down past us again. There's an equation in maths which is v squared equals u squared plus 2as, when v is your end speed, u is your initial speed, a is acceleration, and s is your displacement, okay? Now, if the ball is going up again and past you again, what would be the displacement? The displacement would be 0. Okay, why? Well, because overall, at this moment in time, it's not moved anywhere. Okay, it's just gone straight past you. So in order for this to be happening, S will equal 0. And if we substitute S equaling 0 into the equation, this whole part will be equal to 0, meaning that V squared will equal U squared, or in other words, V will equal U. In other words, if you wanted to see how much the speed, or what the speed would be of a ball if you threw it up in the air and it landed and went straight past you, the speed will actually be exactly the same as if you threw it. So if you want to know how hard a ball would hit, well, you throw it with the exact same speed up in the air, and the exact same speed it will come down is exactly how hard it will hit if you threw that at someone.